In this tutorial, we will look at increasing and decreasing models. The demand for silver alloy is known to fall as the price of the alloy rises. It is also known that when the price is $16 per gram, there is a demand for 900 grams of the alloy. Show that the function P equals 48 all divided by 0.01 Q all to the half, where Q is greater than 0, is a possible model that has the necessary relationships. So there are two things we need to check. First, we need to check that the demand is falling, in other words, that we have a decreasing function. And we need to verify that when the price is $16 per gram, that there is a demand for 900 grams of the alloy. So the second thing to check is faster, and so we'll look at that first. So what this is saying is when Q equals 900, we want to see if P equals 16. So let's substitute 900 into the function. So when I simplify the denominator, I get square root of 9, or 9 to the half. And that equals 16. So it's true, when Q equals 900, the price equals $16. So now let's look at the second thing. We want to show that the demand is decreasing. So when you hear the word decreasing, you should think of the first derivative. So I'll just write P out again. Now let's simplify the denominator. I can apply the law of exponents since I have a product 0.01 times Q raised to the half. I can actually put 0.01 to the half and Q to the half. So 0.01 to the half just means square root of 0.01, and that equals 0.1. So I'll simplify that. 48 divided by 0.1 is 480, and then I'm still left with Q to the half. Now I can bring Q to the half to the top by negating the exponent. Now we can take the derivative, and it's a lot easier this way. Bring down negative a half, and then subtract 1 from the exponent. So I'll have negative 3 halves. Now 480 times negative a half equals negative 240, and times Q to the negative 3 halves. So just as we did in the step above, I'm going to move that Q to the negative 3 halves down. So I'll negate the exponent, which will make it positive. So I'll just rewrite it. P prime equals negative 240, all divided by Q to the 3 halves. We're told that the domain of the function is all values of Q greater than 0. In other words, from 0 to positive infinity. So if we plug any number from this interval, 0 to infinity, into P prime, we get a negative answer. In other words, P prime is less than 0. And that implies that the original function P is decreasing. Conversely, if p prime was positive for all q on that interval, then p would be an increasing function, which is not the case here. And this completes the exercise.